Hello, everybody. My name is Satish. I work as a principal solution specialist at Microsoft. I'm a cloud native enthusiast with a keen interest in integration technology. In today's session, we'll be looking at the core capabilities from Azure Integration Services. Right. So as you see, I've named the session Connect the Dots with Azure Integration Services. So there's a whole bunch of integration offerings from Azure, and we'll be looking at how they add value in building cloud native applications. Right. So enterprises have many applications in their IT estate. So, there could be an ERP, there could be CRM, there could be channel applications and the likes. Now, positive business outcomes are achieved when or value is realized when these applications are able to integrate with each other and interact with each other in a seamless manner. But it's not as easy as it sounds. There are many challenges, right? So each of these applications may have their own interfaces. Each of them may follow different transport protocols. So while some may support REST services, some may support SOAP web services, some applications may be dependent on queuing because they support asynchronous interface. And at the other end, we may have databases as well. So how do we do transport protocol mediation across these wide variety of applications? That's the first challenge. The second challenge is around the data source itself. So each of the applications may support their own data format. So some of them may support XML, some may work with JSON, some may identify with CSV. Legacy applications, for example, support CSV data format. So again, how do we transform messages so that each of these applications are able to understand the different message types? And then the application architecture itself. So while some applications may be monolith, some may be built using service-oriented architecture. So how do we take care of these differences? And finally, in terms of the application where they're deployed. So today, in present scenario, for most enterprises, it's a mix. So there is a mix of applications that are deployed on-prem, as well as there are those applications that are deployed on the cloud. So how do we make these applications integrate seamlessly across cloud as well as on-premise? Now, we looked at the challenges, the need for the integration and the challenges. Let's also look at how this problem can be solved. So in order to address these challenges, what we need is a suite of capabilities or a combination of capabilities. So we need orchestration workflows to take care of protocol mediation, message transformation, routing. We need APIs to act API gateways, for example, to act as security gateways. We need messaging solutions and eventing solutions to take care of different architectural patterns like asynchronous integration, right? Now, let's also look at what are the key trends that are driving integration technology, right? So over the past few years, we've been seeing two initiatives from a business perspective that is impacting integration technology. The first one is most or almost all enterprises have embarked on this journey of digital transformation. And as part of this digital transformation initiative, they are modernizing their existing application. They want to, let's say, break the single large monolithic application into multiple microservices. They also want to gain from, let's say, adoption of cloud. They want to bring in scale and speed in their new initiatives. Additionally, enterprises are also keen to leverage external partnerships. And by leveraging external partnerships, they want to expand their channel and use API economy to their benefit. Now, all these requirements are dependent on the capability of an organization to integrate applications, whether on-prem or on cloud, whether internal or external, in an effective manner. Also, as organizations modernize their application, and create multiple microservices, event-driven architecture takes a lot of precedence or importance. So the ability of an organization to act on events becomes extremely important. And finally, in order to leverage the API economy, it is very important to build and publish APIs for consumption by external parties. Now let's look at the key offerings within Azure Integration Services. So as you can see, Azure Integration Services is a suite of 6 capabilities brought together. So we have Azure Logic Apps, which acts as your integration platform as a service, or this is our core IPaaS offering. So this lets you build integration and orchestration flows. We have Azure API Management, which can act as a full lifecycle API management solution to fulfill your external integration needs and the ability to manage the lifecycle of APIs. We have Event Grid and Service Bus as our core messaging solutions or eventing solutions. So this gives the ability for you to build event-driven applications. And then when you have needs for ETL, extract, transform, and load of data, then we have an offering called Data Factory, which can take care of this. And finally, we have Azure Functions, which is your serverless compute engine. Now, using a combination of all these services, you will be able to achieve all your integration needs. Now, all of these services do not need to be used all at one go. You can pick and choose what is most appropriate for your need and use that service. And as your needs grow, you can pick and choose from any of these capabilities and use them. Now, in the next few slides, we'll be doing a deep dive on some of the core offerings from this list. Let's begin with Azure API Management. Now, API management has grown in importance over the last few years. Every organization has an API initiative to leverage the API economy in order to expand the channel, in order to grow the business. Now, Azure API Management lets you work with your external partners in an effective manner. Let's look at the key capabilities in Azure API Management. Now, what you see here are the 3 key solution areas within Azure API Management, right? So what are the expectations from an API provider perspective, right? So an API provider is building a wrapper on top of existing backend APIs. So the first and foremost thing in the mind of an API provider is, how do I secure the access to the API? So I'm going to publish this API and make this available to the external world. So how do I make sure that these APIs are only available to the partners that I trust? That's extremely important. How do I monitor the usage of API? How do I throttle the number of requests that are pushed in? Now, these are the key expectations from an API provider perspective. So Azure API Management covers all these needs. So from an API provider perspective, they can use Azure Portal or tools like Visual Studio or Visual Studio Code in order to build their APIs, define the policies for security, for access control, for rate limiting, etc. They can also add policies around message transformation, caching. So the publish module within Azure API Management provides the capability to the API provider to be able to define their APIs. Now, once the API is defined, it's published and it's made available in this green layer, which is the API gateway layer. Additionally, the API definition is also sent to this red box, which is nothing but the developer portal, right? So once the API becomes available in the gateway and the developer portal, the partner app developer who is interested in consuming your API will be able to look up and get the details of the APIs from the developer portal. So they get the details from the developer portal. They start building the application, the first and third party applications, And then during runtime, when a call is made, API call is made, it passes through the gateway. So the gateway, the green layer, becomes your policy enforcement point. So this is where all the policies that you define on your API around security, around access control, around rate limiting, around transformation, around caching, around routing, all of these policies are enforced at the gateway layer. And then from the gateway, the API call goes to the backend application, and the response then follows the same path. So Azure API Management is a full lifecycle API management solution that can cater to all your API management requirements. We'll also see a demo on Azure API Management. Now, moving on, Azure Logic Apps. Again, as I mentioned earlier, this is the integration platform as a service, or IPaaS offering from Azure. So this takes care of all your integration and orchestration workflow needs. Now, Logic Apps provides an effortless UI-based experience for building your workflows. So you can build these workflows on Azure Portal or on Visual Studio or Visual Studio Code. So you will get a drag and drop experience whereby you can define triggers which would invoke the start of work, which would invoke the workflow and start the workflow. Now, these triggers could be many things. So it could be invocation of an HTTP endpoint on Logic App. It could be appearance of a file in a folder or a blob storage, for example. It could be appearance of a row in a database table. It could be events like creation of a customer record in a CRM system and the likes. Now, when any of these events happen, the Logic App integration workflow gets triggered, and then you could do multiple things. You could do transformation if needed. You could invoke multiple backend systems and basically orchestrate across these different backend calls, create the response that's needed, and send it back to the caller. So it really provides an easy manner to quickly build your integration workflow. Let's look at how Azure Logic App enables seamless connectivity. Now, Azure Logic App provides connectors to enable connectivity across applications that could be deployed on cloud or on premises or other cloud. So in the present day, right now, we have more than 400 connectors as part of Azure Logic Apps. Now, all of these connectors have actions defined in them to perform, let's say, transformation, to perform orchestration or sequencing of the way the messages are handled. Now, these integration workflows that you build using Azure Logic Apps, they could be built on Azure Portal, Visual Studio Code, or Visual Studio itself. Moving on, we now go to the eventing and the messaging solution from within Azure Integration Services. So Azure Event Grid basically simplifies creation of event-based applications. So you could have a bunch of applications that can act as event publishers. For example, if a file appears in blob storage, you would want a function to be triggered. So that can be achieved using Event Grid. So Event Grid can act as the bridge between an event publisher as well as an event consumer. From an ops perspective, whenever a new SQL database is created, for example, or whenever a new virtual machine is created, if you want to run a series of compliance check, then again, you can leverage Event Grid, whereby creation of these resources within Azure will trigger an event. Event Grid would then publish that to an Azure function, for example, which would run the compliance check. So event-driven applications can be built using Azure Event Grid. Now, let's look at the capabilities of Azure Service Bus. So there are scenarios where you would want to leverage messaging as a service. Azure Service Bus is a managed messaging solution from within the Azure platform. Now, because it's a managed service, there are many advantages. So it's a fully managed service. You do not need to manage the underlying infrastructure. It scales automatically based on the throughput of the messages. There is inbuilt monitoring to monitor the message throughput as well as the success and the failure. It is secure by design. It supports TLS-based security. It supports encryption of data at rest as well as during transit. Finally, it also supports JMS messaging standard, which is becoming an industry standard. That was a quick tour of the core capabilities within Azure Integration Services. There are thousands of enterprises around the world that use Azure Integration Services to overcome their application integration need challenges. We looked at the core capabilities of Azure Integration Services in the presentation. Now let's see that in action. So I'll be doing a demo of Azure API Management and Azure Logic Apps next. Let's look at the demo by looking at the capabilities of Azure API Management. Now, Azure API Management can be created from Azure portal, or you can also automate the creation using ARM templates. Now, if I click on create, so for this demo, I have pre-created an Azure API Management instance, but if you look at this screen, you will see that a lot of configuration information can be provided at the time of creating API management, including the SKU that you're interested in for your API management solution. So based on your enterprise need, you could choose what is most appropriate. Then you could provide your requirements around monitoring, scaling, how you would want to control authentication and authorization of this solution with your core backend APIs, whether you would want API management to be part of your virtual network in order to enable access to backend APIs, etc. Now I have pre-created an API management instance. Let's go to that. So this is my API management instance that I've already created. So you can see that I have deployed this in the Central India region. You also see that when I create an API management instance, there are two URLs that get generated. One is the gateway URL. So this is the API gateway URL from where the APIs will be accessed at runtime. And this is the developer portal URL. So this is where organizations that are interested in consuming your API will look up to get the details of the API itself. Additionally, there are details around virtual network, caching layer that is used with API management, etc., and how many APIs are created already. Now, the core part of developing the API is covered under this API section. So let's look at how APIs are created in Azure API Management. Now, when I clicked on the API screen, I land here. So this section shows all the APIs that are already present in Azure API Management. If I want to create a new API, I can click on Add an API, and you can see that various types of APIs, backend APIs, are supported. So it could be an HTTP endpoint or a WebSocket or a GraphQL. Additionally, if you have a traditional SOAP or a REST-based web service backend and you want to enable GraphQL on top of that, that can be achieved as well. And then if you have definitions like a Swagger file or a JSON file that defines your OpenAPI or WSDL file that defines your SOAP web service, all of those endpoints can be used to build your API. Finally, if you have existing Azure resources like a Logic Apps integration service or a container deployed on container app, all those endpoints can be seamlessly exposed as an API using Azure API Management. Now, again, I have pre-curated certain APIs here. Let's look at the settings. So this is a demo conference API. So it's a endpoint that talks about an event which has multiple, or a conference which has multiple sessions. Now, if you look at any API, there are multiple operations in each of those APIs, and you could apply policies in those operations. So if you look at this section here, I have added a caching policy. So whenever, for example, there is a call to get session details, for example, or fetch session details, I do not want to invoke the backend every time. So I want to cache that response and then look up the cache for a period of time. Now, policies like this can be easily added. There are more than 50 policies that are already pre-built and made available. So these policies could be around authentication, these policies could be around caching. If you want to apply rate limiting based on the caller IP or based on the identity of the caller, that can be done using the usage quota policy. If you want to do transformation, there are multiple policies that are made available. So for example, if you want to do JSON to XML or XML to JSON, all of that can be achieved using these policies. There are again policies for validating the content. So whether the incoming request is valid or within the size range that you define, whether the parameters are valid, all of these can be checked using these policies. Now, once you have built your APIs and defined your policy, you can begin testing that. And we provide a test window within the API management development experience. So I want to test, for example, the get topics API. So this expects an input for the day on which I want to get the conference topics. So I give 1, and when I click on invoke, what I should see is I get a response 200 okay, and I get the bunch of sessions that are planned for day 1. So you get capability to not only define your API but also test the APIs in the same window. Apart from this, you can also create multiple versions and revisions. So if you see this example, post the creation of the API, I added caching capability. I enhanced security capabilities. So all of these changes are reflecting in the versions and revisions tab. Now, once you have defined your APIs, in order to make them available to your end consumers, you would typically create products. So in the API economy, products is the means by which you share your APIs to your end consumers, right? If I go to the settings here, I can choose the products to which I want to deploy. So I have chosen these products, the API products, where let's say this conference API is available. Now let's look at these products, how they are and what you achieve using this product construct. So if you look at the product, let me look at unlimited product. What you do here is you define policies around access control. So if, for example, in this product, anybody who's a subscriber to this product will get unlimited access to your APIs, right? So you create a product, you start adding APIs that are existing in this product. You can also define policies around rate limiting in the product, and you can define access control policies as well. Who gets access? Who are the current subscribers? You get to see all of this information here. Now, let's say you have a subscription, but that particular subscription is breaching the contractual terms with the API. You get the ability to cancel the subscription or delete the subscription as well. So product as a feature is extremely important in the world of APIs, especially when you expose the APIs to the outside world. Moving on, policy fragments is again one very important feature. Now, by way of policy fragments, you can code the policy once and then use that in multiple different APIs. So this kind of makes your development effort more efficient. So this, for example, in this policy here, I've created a fragment for creating a header and sending this to backend calls. Now I can create such policies which are reusable in different APIs and then use them. So this particular policy, for example, forward context header information is being used in 2 different APIs in my usage. So it's being used in demo conference API here, for example. So this enables reuse. If now moving on, once you've built your APIs and you've published them for usage, monitoring the usage of the API becomes extremely important. And within Azure API Management, a lot of analytics information is pre-built and made available. So if you look at this, for example, you can look at the API calls that have been happening over the last 15 minutes, the last 7 days, or to the last up to last 90 days, the data is retained. You can, of course, extend the retention period based on your need. Not only you see the number of invocations, you also see details on the amount of data transfer, the average response time, how many times caching was used. Additionally, you get analytics information around from which corners of the world the API invocation happened. In my case, for example, there were API invocations from within India and USA. You get to see which APIs got invoked the maximum number of times, so you get details around that. You also get details around which operation within an API, which product invocations happened, and who was the subscriber who made the API call. So today, if you want to monetize based on the number of API invocation done by a particular subscriber, you get all the data that is needed for that monetization from this pane. Right. Finally, as I mentioned earlier, API Management Gateway can be deployed on-prem as well. So if you look at my screen here, I have created a gateway that's deployed on my laptop. So I will be able to view the APIs that are deployed in this particular gateway, which is on-prem or on my laptop, and then also get analytics information based on the APIs that are deployed on-prem. So I can go here and choose the APIs that I want to deploy on-prem. What I have on-prem is a container that I'm running on Docker desktop. So this is the API gateway. So this way you see that API management can be deployed on-prem as well as it can be Azure managed. Now that was a quick overview of Azure API management. In the final part of the demo, let's look at the capabilities of Azure Logic Apps. Now, as I mentioned earlier, Logic Apps is the IPaaS capability or integration platform as a service capability from within Azure. Logic Apps provides you the capability to build integration workflows. So you can, again, you have multiple SKUs that you can choose from. This, for example, is a consumption logic app. So for this is completely serverless and you pay based on the usage or the number of invocations. But there are other options, for example, Logic App Standard, which is a single tenant offering. So you can create a Logic App Standard and provide the compute capacity based on your need and build integration workflows based on your need. Now, in this example, what I have created is a workflow which gets invoked by the appearance of a particular file in a folder. So I have my OneDrive. So whenever an invoice gets created in and placed in this folder, I want this workflow to be triggered. Now, once triggered, I want to leverage Azure's OCR service, form recognizer service, to read that PDF and generate information like the invoice due date and the invoice amount, etc., and send that to my finance team. So this is exactly what I've done. I have read the file from the folder. I have analyzed it, leveraging other Azure service, OCR service, and then I'm sending an email based on that. So let's look at the development experience. So this is the Logic App Designer. This is currently on Azure portal, but you can use Visual Studio Code as well. The trigger for this is when a file is created in a folder, but it could be anything, any trigger of your choice. And then I already mentioned the action. Now, if I need to edit this workflow, I can add an action very easily. And here I can leverage all the 400 plus connectors and the various actions that are present here. So if I need to connect to Azure Cosmos DB, or if I need to connect to any external application, for example, Salesforce or SAP, there are connectors that are available which I can leverage in building out my integration logic. And this logic can be deployed in a serverless manner or in a single tenant manner using Logic Apps standard. Thank you all for joining today's session. I hope you found this useful. So, where we looked at the key capabilities of Azure Integration Services. Now, I have shared the links where you can find more information on this offering. If you have any further questions or if you want to find more, please do reach out to us and we will be more than happy to help you or assist you in fulfilling your integration challenges. Thank you again.